This is the review for Chapter 10. And we're given these lengths of 5 and 12. We're told that this is a right triangle. 5 and 12 are the legs, which means that the hypotenuse is going to be 13. Using Pythagorean theorem, or recognizing that it's a Pythagorean triple. This segment AB is perpendicular to that tangent. This segment, which I'll call AH, is perpendicular to that tangent. So we have a rectangle here in the middle, since all of the angles must be 90 degrees. And then since this radius equals that radius, it's not just a rectangle, it's a square. So all of these sides are congruent to each other. To find the radius of the circle, I'll call this length x. That means that the radius of the circle is also x. Using a bit of a walk around, I know that these lengths reach 5 minus x. I know that these lengths reach 12 minus x. So then if we add these expressions together, 5 minus x plus 12 minus x gives us 17 minus 2x, which must be equal to 13. 4 equals 2x, so x, the radius of the circle, is 2 units. It's part of our answer. The other part of the answer is to find the measurement of arc angle BEF. To do that, we're going to have to calculate the measurement of angle G. Using the entire triangle, ignoring the circle, I have a right triangle. So the tangent of angle G is equal to the opposite of 5 divided by the adjacent of 12. So G is the tangent inverse of 5/12, and that is approximately 22.6 degrees. Now the reason why that's important is because one of the equations I'm going to get at this point is that the measure of angle G, which isn't a variable anymore, it's something I know. I should store that as some letter in my calculator. Measure of angle G is equal to measure of arc angle FHB minus the measure of arc angle BEF divided by 2. So there's one equation relating those two arc angles together. Those are my two variables, or my two unknowns. I also know that the measure of arc angle FHB plus the measure of arc angle BEF is equal to 360 degrees, because together they form a complete circle. So then if you use this equation, again with those two variables, with this equation with the same two variables, you could use elimination or substitution to solve for our goal angle, which is the measure of angle BEF, and that angle comes out to approximately 157.4 degrees. In this one, since C and E are the circles, it means that AE is a diameter in the smaller circle, which means that this is a semicircle. So this inscribed angle, angle D, has got to be a right angle. It means that this must be a right triangle. More specifically, it's a 45-45-90 triangle. And if this is 45 degrees, then its linear pair has got to be 135 degrees. So angle AEB is 135, and it's a central angle for arc angle AB, which is the one we're trying to find. So the measure of arc angle AB is equal to 135 degrees. This is problem number 3b. I notice that the coefficients on x squared and y squared are the same, and they're both fractions, so I'm going to multiply everything by 4 so that I don't have that fraction in there anymore. I'm also going to organize it so that all of my x's are together and all of my y's are together. When I multiply 4 times negative 2, it's negative 8, but I'm going to add it to get it to the other side. To complete the square for the x's, I take half of 4 and square that, that's 4. And to complete the squares for the y's, I'm going to take half of negative 4/3, that's negative 2/3, square that, and that is 4/9. Since I added 4 to the left, I have to add it to the right. I added 4/9 to the left, so I have to add that to the right. If I look at the factoring here then, this is going to factor as x plus 2 quantities squared. The second part is going to factor as y minus 2/3 squared, because negative 2/3 times negative 2/3 is 4/9. Negative 2/3 plus negative 2/3 is negative 4/3. And my little shortcut to remember that is whatever this b value is, we divided it by 2 and then squared it. When we divided it by 2, that's always going to be the number we have in here at the end. If you add all of these numbers together on the right, you get 112 over 9. So now we know that the center is negative 2 comma 2/3, and the radius is the square root of 112, which will simplify down to 4√7 over the square root of 9, which is 3. So there is our center and radius. This is problem number 8. Jn is equal to 8. That's the radius of the circle. So that means that Jk would also be equal to 8, Jo equals 8, and Jm equals 8. In other words, this entire diameter has got to be equal to 16. If that length is 16 and Lm is 25, that means that Lo is equal to 9 units. We have a few more things we need to find. One of them is not Kn, but it is going to be significant, so I'm going to find that right now. To find the length of Kn, I would say that 10 times 10 plus Kn is equal to 9 times 25. We're using the formula for intersecting secants outside of the circle. That's 100 plus 10 Kn is equal to 225. Solving that for Kn, Kn is equal to 12.5, or 25 over 2. So we'll fill that label in and move this work off to the side. We want to know, what is the measurement of angle LJN? Angle LJN, which is part of this entire triangle. If I focus just on that triangle, I know that the length of LJ is equal to 9 plus 8, or 17. Jn is equal to 8, and the length of Ln is equal to 22.5. So to find this angle, we can use law of cosines. And when you use the law of cosines, this angle LJN is approximately 124.3 degrees. Store that in your calculator as a variable, because the next thing we're going to need to find is the length of segment KO as well as the measure of arc angle KO. This entire angle is 124.3. However, if I want to focus on a smaller triangle, which would be this one, I could use law of cosines in order to find the measurement of angle KJN. 12.5 squared equals 8 squared plus 8 squared minus 2 times 8 times 8 times the cosine of this angle. So if I can find the measurement of that angle and then subtract that from 124.3 degrees, what's left over is this little angle on the side, angle OJK. That's a central angle that corresponds to arc angle KO, and that's going to give me 21.5 degrees for the measurement of that arc angle. The last thing that we're going to find is the length of segment KO. Not the arc length, but the segment length, the length of the chord. Good thing is that in this triangle that I've just highlighted, we know that this length is 8. We know that this length is 8. We just figured out this angle measurement to be that approximate 21.5. So as long as you still have that in your calculator or stored, you have a side angle side, so you can use law of cosines to find the length of segment KO, and that is about 2.99 units.